All right, continuing to find limits of functions in indeterminate form, we're going to deal with one that has a rational problem in it. Not only is it rational function, it involves a radical of some sort. So we're going to have to do what's called rationalize the numerator. And so this is the technique called rationalize the numerator. And let's take a look at our results we should expect. So here's 2 minus rad x, and here's x minus 4. And we're going to check out what happens to this graph as x approaches 4. As you can tell, 2 minus rad 4 is 0, and also 4 minus 4 is 0. So we got the indeterminate form of 0 over 0. I'm just going to go ahead and make a table here in Desmos for a minute by clicking the table function. And then this is already x and h of x, as this is good. This is kind of what I'm looking for. Negative 2 is undefined. Oh, negative 2 and negative 1 are undefined because they make negatives underneath the radicals, and I can't have negatives underneath the radicals. That's why these graphs don't exist over here to the left, because of the negative underneath the radical. So f of x, or for that matter h of x, does not exist to the left. So let's take a closer look around 4, for example. So I want 3.9. I'm going to put in also the point 3.09. I'm going to put in 3.999. I'm going to go with 4, 4.001, 4.101, sorry, and last but not least 4.1. Okay, we can tell from the table, it looks like 3.9 and then 3. Oh, sorry, this should be a 9. It looks like 3.9, 3.99, and 3.999 are getting closer and closer and closer to negative 0.25, which is negative a fourth. Also from down here, we go to negative 2.4998, 2.4. So again, we're getting closer and closer to negative 0.25. So I'm going to propose to you that the limit of the function of f of x over g of x as x approaches 4 is actually negative of 1/4, even though, and we can see this happening in the graph down here, even though it's indeterminate form if we use direct substitution. And let's see what this looks like by hand. So I'm going to go ahead and solve it out by bringing my presenter window up again. All right, so I want to review just a couple of things first. 3 minus x over x minus 3, those two things can be canceled. They are in fact opposites, and they would have a result of negative 1. So if I took 3 minus 6 would be negative 3 up top, and 6 minus 3 would be positive 3 in the bottom. That would give me negative 6 divided by positive 6 is negative 1. And by the same token, the sum and the difference of the same two binomial products over here gives us the difference of their squares. And this is what's going to help us rationalize the denominator and factor some things out. So let's go back to our original problem for a minute. I'm pretty sure it was f of x is equal to 2 minus rad x all over x minus 4. Okay, so again, if we look at the limit, as x approaches 4, 2 minus the rad 4 is 0. 4 minus 4 is 0. That's indeterminate form. So the question is, can we do something with it? And in this particular case, we're going to multiply the numerator by its conjugate, it's called. So what I'm going to do is take 2 minus rad x in the numerator and multiply it by 2 plus rad x. Anything I do to the numerator, I have to do to the denominator, x minus 4 times 2 plus rad x. So in general, I've just taken my original function here. Sorry, let me square it up. My original function here, and I've multiplied it by 1. Obviously, anything under my pin here just equals 1. It's the same number over myself. Big mathematician trick, multiply things by 1. So now I just got to number crunch a little bit. 2 times 2 is 4. Let me move it up. 2 times 2 is 4. Minus rad x times rad x is just x over, and don't even do anything with this bottom. Just go x minus 4 times 2 plus rad x. And this is still f of x, still limit as x approaches 4. Okay, so now we know that this problem has a discontinuity. We know that 4 creates a hole in this graph. The question is it a hole or is it a vertical asymptote? And we're going to say, since it was 0 over 0, we think it's a hole in the graph. Can remove this by factoring. Same as we looked at up here, 3 minus x over x minus 3, 4 minus x over x minus 4. This is just negative 1 over 2 plus rad x, limit as x approaches 4. So if I use direct substitution now, I get negative 1 over 2 plus rad 4, which is negative 1 over 2 plus 2, or negative 1/4, which is kind of what we thought to begin with. So the limit of this particular function as x approaches 4 is negative 1/4. All right, just what we thought with the graph. Thanks.